Hey guys, welcome back to the channel. Fire is the heat energy released after certain chemical reactions. Whenever fire burns, oxygen is added to the fuel that is burning. That is why burning is often considered as an oxidation process. Fire occurs at the presence of three major components. They are fuel, oxygen, and heat. These three constitute to form something called the fire triangle. Those of you who had attended fire safety drills would have learned about this. The triangle illustrates the three elements that are required for ignition. The first one is fuel, the second is an oxidizing agent, mostly atmospheric oxygen, and the third is an external heat source. Without either of the three, it is not possible to generate fire and transfer heat energy. A good example to explain this is the cooking stove. The fuel here is the LPG gas, oxidizing agent is the atmospheric oxygen, and the heat is produced from a match or spark from your handheld lighter. When you combine all three, you light a fire in your stove. Remove either one of them, poof, no heat to cook your food. Even though fire is one of the most crucial discoveries of mankind, it does have a few disadvantages. Just like we explained, it is highly dependent on external factors. Apart from that, fires with certain types of fuels leave soot and ash. There is also an issue of irregular transfer of heat. The points which are in contact with the fire have a much higher temperature than the rest of the object. This is a huge issue when metals are heated for metallurgical processes like forging. The uneven heat distribution can result in hard and soft spots on the metal. This could sometimes be disastrous and damage the forging equipment. But what if we told you there is a way to heat materials without using fire? Lasers? No, it's by using electricity. When we say using electricity, the first thing that might be coming to your mind are the electric heaters that you see in many households. But we won't be discussing that. Instead, in this video, we'll be discussing a different procedure of heating called induction heating. Electromagnetic induction heating is a method of heating electrically conductive materials. This method is most commonly used in metal working processes such as forging, welding, heat treating, and melting. As the name implies, induction heating relies on the electrical currents that are induced in the workpiece. The components that are involved in an induction heating system are an AC power source, an induction coil, the circuits, and the workpiece. In this video, we'll explain why the workpiece gets heated. When an alternating current of high frequency is passed through the coil, this causes an alternating magnetic field to surround the coil. This is in accordance with the laws of electromagnetism. The workpiece is then placed inside the coil. This causes the magnetic field from the coil to induce an electromotive force along with eddy currents. This is somewhat similar to a transformer. The reason as to why this occurs can be explained by Faraday's laws of electromagnetic induction. We can consider the workpiece as single-turn short-circuited secondary windings. You should have learned about the eddy currents in our previous video. If you haven't watched it, the link is in the description. The eddy currents flow inside the conductive material in loops and generate their own magnetic field. When the eddy currents flow inside the material, they'll experience resistance towards flow. This causes the material to heat up. This is because of a phenomenon called Joule heating. Joule heating is also the reason why incandescent bulbs glow. The induction heating is also the same phenomenon behind the induction stoves which are used in houses to cook. The inside of these induction stoves is very much similar to that of industrial heaters. They have a copper coil which is used to generate a magnetic field and all the circuits behind it. If you're someone who's used the induction stoves, you would have noticed something very peculiar with them. You can't use vessels made with ceramics or plastics. The main reason behind this is that these materials are bad conductors of electricity. This is the biggest limitation of induction heating. Only materials which conduct electricity can be used for induction heating. This is also the reason why you'll see vessels which are sold separately for use on induction stoves. The biggest advantage of induction heaters is their efficiency. Heat can be transferred with very high efficiency. Sometimes it is as high as 60% as opposed to 15% of gas-fired heaters. The formation of scale and scrap is also very less in induction heaters. The heat is also transferred uniformly throughout the material instead of only the points of contact between the flame and the material as in gas heaters. Well, that's it for the video, guys. We'll meet you again in the next one. Till then, bye.